Hi, welcome back to Mini Rust in Rust. This is video 43. We're writing a programming language that it looks like Rust. It's like basically the syntax of Rust. So far, only the simple bits or a tiny snippet of the simple bits. We're writing the code in Rust. We're doing it to kind of learn about, I don't know. We're doing it because I like writing programming languages. And we're finding out it's a massive amount of work. Okay, so last time we got things like this to work, where the right-hand side of an operation is not just a token, but is like some kind of compound expression of itself. And I'm pretty sure the left-hand side of this won't work. So let's do a couple of fiddles. First of all, before we do anything else, I just got curious about what happens if we had addition here. So I just want to, I think it'll work. Like the changes we made last time should make it work. It does work. It's just like my assertion is wrong because it's a less than it's a plus, not a less than or equals, and things have moved around. So it does work. So that's good. And let's just continue with using plus as our example instead of less than or equal to just increase our coverage a bit. And let's say passing, this should be called parsing operation. The fact that it's less than or equal is not really relevant. And similarly here, this should be parsing operation handles non-token on left. And this is not going to work, I think. Let's just try and make our test look approximately like how it should be. So it's going to be a block containing nothing and then the number 29, which starts at 0, 1, 2 for 2 characters. And then this should be 2, 3, 4, 5, 6, 7, 8, 9. So this starts at 9 for 1 character. I mean, I don't know why I'm doing the fiddling bit when the hard bit will be, well, this should be, I think it's plus. And that's from 0, 1, 2, 3, 4, 5, 6, 7 for 1 character. I think I sometimes do the dumb stuff to give my brain a chance to settle itself. So when I get onto the difficult stuff, I'm ready. All right, so the difficult thing is that I think at the moment we expect there to just be one token on the left-hand side of an operation, not some kind of compound expression. So is it going to be as simple as just saying I'm expecting an expression? Okay, so it fails because it doesn't even look for an operation unless it just found a token. So let's think about, I think this involves another bit of a restructure to our parser. So at the moment, when we're parsing an expression, we get hold of a token, and then after the token, we expect either this is just a leaf token on its own, or it's an operation where like something happens after the token, or it's some other stuff. And we don't, if we've parsed a whole expression because we found, say, a brace open, and we looked for a block, we found a block, then we're done. Then we're done. And we're not done necessarily. So I feel like actually this whole thing should be in some kind of while loop. Saying once you've finished parsing a block, I mean, not a while. Once you've passed a while, your expression is over. Is that right? No, but if you passed a while, it could then be like that. That while could produce a value which you then want to like add 1 to or something like that. So maybe a let like has to be a statement. So if it's not a statement, that would be weird. So that could be, I mean, maybe it'll never happen because the right-hand side of a let is already an expression, so this will be dealt with in some way. But anyway, let's not think too much about lets now and see if any of our existing tests fail. But let's say, generally, how you parse an expression is not find a token and then there might be an operation after it. It is find a token, there might be an operation after it, but also if we've parsed a whole thing, there might be an operation after that too. So there's some kind of thing here of saying do the same thing that we do inside here, outside here in some kind of while loop. So let's start just looping forever and expect to return when, all right, well, certainly we're going to return when we hit an end marker. And what else? These things. And we're not necessarily going to return, well, we probably are going to return if we find an assignment. Let's put that in for now. But if we find a while or a block or some kind of operation, then we might find another operation after it. And interestingly, then we'll have to deal with the order of operations, which will be interesting. But let's think about that later. Like at the moment, we're going to, if we go this way, we're going to produce a kind of arbitrarily nested chunk of operations. And I actually feel like what we should do is we should find a list of operations and then allow precedence to happen later. So is now the right time to think about that? Like instead of just looking for one operator, we should be looking for a whole chain of plus and minus and less than or whatever. And the outcome of that operation chain will be like kind of one syntax tree, not a nested thing. And then we'll reduce it down to nested using operator precedence later. I think that's the right way to think about this. But yeah, so basically we want to find one of these things like a while loop, or let's say the easy thing is the example we've got in our test, which is find a block, put the answer into a variable, and then if we do it again, maybe we don't need a while loop. Maybe we just need to do it kind of one more time. Let's start by doing something really dumb and see. So let's just have a mutable variable, which is an empty vec. And we're gonna, every time we find something, we're gonna add the answer to ret. Like this. And push it in there. I don't know why I called it new, that's a terrible name. Next. Expr. Something like that. And then at the end we're going to return, well hang on, when are we going to return ret? I guess when next expr is none, that's when we're going to return. What is next expr right now? I think it should be an option, yeah. So if next expr is none, we just return ret. So if next expr is not none, then we've got more to do. Otherwise, so if it, yeah, otherwise we're going to return ret without adding nextExpr because nextExpr was a thing. But of course, ret's not got the right type. I think it's right because it's not a vec. It's like the current return value. The current return value is nothing. We haven't found an expression. And we want to return the current. We want to pass in the current return value instead of this token somehow. So or maybe as well as. So if the next expression was none, we return what we've built up so far. Otherwise, we hang on to what we've built up so far, like so. Like this. So this should be like something, right? That's, yeah, okay, that's what I meant. Okay. So basically, if we found something by whatever we were doing, the answer should be that thing that we found, that kind of compound expression we found by passing what we've already found so far in and then adding it on. So this isn't going to work, but does it break everything? Oh yeah, it breaks everything. It breaks everything. It breaks let. Why? How does it break let? What? I'm a bit surprised by that. Even stuff. All right. I think the thing is that in a lot of the failures here are that we're returning none. I think. I mean, it should. If it finds let, it should just return from here. So how have I broken the examples that pass let? I don't know. Okay. So I knew this wasn't going to work because. Okay. All right. So it's something to do with the fact that. All right. So yeah, the first time around this loop, we put the answer into nextExpr. And the next time around the loop, we match. Sometimes, like we're going to match on the like. Don't know what this is, so maybe it's an operation. We get the answer back that there's nothing there. Then we ought to return ret without modifying ret, so it should work. So why doesn't it work? But more importantly, in the case, well, no, not like everything fails. So I missed something bad. So I guess we need to focus on the simplest possible example. So parsing an assignment fails, saying I expect an expression here. The thing is that you shouldn't be expecting an expression there, I guess, but that is an expression. But maybe x equals 3 is not an expression. So it really feels like we hit the keyword let. So we got into here. We called assignment. Oh, you know what? And then does assignment end up calling expression? And that expression never stops parsing, I reckon. Because somehow, maybe we're not getting... No, I mean, it does stop parsing, but we're somehow getting back a none, and we're throwing out our expression. So maybe this comes back as non-none. Maybe because it comes back as an error. Yeah, it could be something like that. Okay, so how are we going to deal with this? Maybe my whole reasoning's wrong. So let's have a brief think about whether my whole reasoning kind of makes sense. Now, obviously, we're going to have to pass in ret here instead of just token. I mean, yeah, it's weird. It's weird. Like this, maybe this thing is not sensible to reuse. I think this thing is not sensible to reuse because, yeah, this is not quite right. It's not quite right because this thing here, this leaf for operational mutation or unrecognized, it goes and fetches another token. So this is definitely not right. So we're not just looping. We get out of a token and based on that token, we decide what to do. So that's something like if we hit an end marker, we stop. If we hit a let, then we just do an assignment. If we hit something else, like while, then we pass a while loop and then possibly do more. If we hit a block, we pass a block and then possibly more. And if we hit an operation, then we pass the operation and then possibly more. But if it's a mutation, we don't. So that's a bit weird there. So the question is, maybe these returns should come back. Maybe like hitting a let, we just return, and that's fine. But if it's a while or a block or a thing, there might be more. So we've got this next expr. Oh, this should be, I mean, this should really be called first expr. We passed some stuff, but there might be more. So we want to grab another token. We want to do something a bit like, no, we want to actually, let's just grab another token. Let's do it explicitly, and then later we'll be clever. So we grab a token. If it's an end marker, give back the token and return what we've already found. So now we know it's not an end marker, but we have got a token. Oh, if there was no token, we don't just want to quit. We want to say yeah, we want to get hold of, there's some kind of token, otherwise we're done. So we can return same thing. Oh, we need a return below as well. So if there's no token, return. If there was a token but it was an end marker, return. Otherwise, we've got a token, it wasn't an end marker, it does exist. So it could be an operation. I think operation is probably the only thing it could be. So let's look at how we handle that inside here. This is a thing that we need to work on, but it's not relevant. Oh no, well, maybe not. Anyway, so what we do is check whether it's an end marker, which we've already done. and then we check whether it's an operator token. So this is the code I wanted to copy, possibly including the body of the if here. Now mutations are separate and different, so it's good that we're not handling that case. Otherwise we stop. So we want to do something really similar. So let's just see how it looks when we paste it in here. Get rid of this stuff that's not right. So if the token that we've found is an operator token, then get hold of the right operand and then what we're going to return is going to be an operation where the left hand side is, so what is it, sum OK, syntax tree operation, where the operator is that operator token we found. The left hand side is, what's it called? First Explorer. And the right hand side is right. Otherwise, it wasn't an operation. So we just put the token back. And return First Explorer. And it would be nice if we could handle all of these cases where we put the token back. Or these two cases, the case where we put the token back and return the thing, maybe they could somehow be joined together. I don't know. Anyway, think about that in a second. Let's first of all get this at all working. So I got an error. Well, we just got our curly brackets wrong. We're really stuck then. So what does that match up with? The else part there, which is, I think, right. But the end of the function, somehow we're more indented than we should be. If I just delete the extra curly bracket, it'll reformat and we'll see that everything is broken. Okay, it's all broken because this should all go inside. No? Okay, First Explorer is an option of result of syntax tree. So if First Explorer, so we should definitely, if First Explorer is none, we should probably just return none. So I think we should question mark on the option and question mark on the result. But no, the second question mark won't work. So we need to do some kind of if there's an error. So First Explorer is like the result of running this whole expression logic. It could be none, in which case this question mark makes us return. But it could also be an error. If it's an error, we want to return some of it. Yeah, some of it, right? Is it going to let me do that? Because First Explorer's got used up. What's First Explorer? What's First Explorer? It's an option But if the thing inside is an error, just return it. Return the whole thing. Right? Okay, now we've got some problems. Leaf token should be... Now, why do we even pass in leaf token here? Is it just for error handling? No, it's because we actually construct the operation inside here. So we need to be able to pass in a syntax tree here instead of a leaf token. So let's try just saying, what if we just passed it in here? Like so. Now there's going to be places where that's not okay. But here this is going to be a question of now passing in that first expression. And what's going on here? Operation itself already returns. No. Oh, we need to box something. Is that what it's saying? The arguments are 2 boxes, whereas first express and right are both just syntax trees, not boxes. And result, right is actually a result as well. So I guess we need to, no, we can't question mark it. Well, so we'll sort out right in a second. First of all, we'll just put first express in a box. And now right, if right is an error, so let's say it shouldn't be an error. If it is an error, then we need to return. We already, we need to return we need to return we need to return that error, right? Maybe. What does an error from right operand mean? It might mean, so we hit an end marker after, we hit an end marker after something that already told us we expect an operation to happen here. So now we've got a syntax tree. It should be a box of syntax tree. But we've moved first expr when we passed it in here, and then we're using it. Well, that's because this is already, we don't need to construct an operation. Operation right operand already constructs an operation for us. So I think we just need to return the result of calling operation right operand. Not do this. I've done extra work here. Okay. It looks good. Now here, where did we move it? We moved first expr here. Yeah. Can we take a reference to it? Now we've got a reference to a syntax tree. Can I just dereference it? Looks like it. No. So we got to copy it. So how is this? What's the pain of this? We've got this thing which is an option of a result, and we're calling question mark on it. So we could instead just check its. No, the problem is. Oh, is that fixed it? Maybe we just suppressed that error by having these errors. If that's fixed it, I then have to go back and think about why. Okay, it seems to have fixed it. Yeah, okay, so question mark was taking ownership of it. Although maybe the let was taking ownership of it, but we already, like, we were doing two things, question mark and this let, what is the right, matching it. We were question marking it and then trying to match on the result of that. And then if we didn't get into the matching on the result, we were then returning the thing that we had already question marked on. So the ownership of it was messed up. But in this case now, if we get inside here, we're done, so we can return it. Otherwise, we've taken ownership. Yeah, so we either haven't taken ownership of it because the let didn't match, in which case we can return it, or we have taken ownership of it because the let did match, and now we never use it again because First Explorer is it. So yeah, by just kind of simplifying this down to don't question mark it and then match on it, just match, do a more complicated match, we got rid of our ownership problems. All right, so we've still got some errors. Oh yeah, and that's because in this case we need to we changed the signature of this right operand function to take a syntax tree instead of just hard coding it to always be a leaf token. All right, if this fails, I'm lost. If it passes, I'm so happy. Okay, it passed. Our new test passed, right? Yeah, we made a new test. I'd like to see it fail now because I got worried. So where's that? Around 91114. Okay, so what if there's just something that doesn't pass here? Our test should fail. Yep, handles non-token on left failed. So this test is passing. So now we can have blocks like this, which is amazing. I'd like to do that in a while, just to make sure. In a while loop, not just in a while. So let's do this. And I mean, it would be nice if we could do both sides being blocks, but let's not go mad. Let's start off with just this one. So while passing a while condition, turning open brace before operation. Let's say just something just to let us run this test. So that did indeed pass. It's just like our test specifies that it looks different from how it now looks, because now it is a less than or equals operation, which contains a block and then a leaf. And like so. It's a block of a 3 and then a 4, but the actual positions of them are different. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be from 8. And then 9, 10, 11. And then from 11. And the less than or equal operation is going to be from 12, 13, 14, 15. 2 characters, and then 15, 16, 17, 18, and then that is going to be 18. Right, is that going to pass? It passes, okay. So, look, we can pass really nasty, weird, complicated things. And I'm glad that we actually made the effort of doing this whole syntax tree thing, so that we know not just that it doesn't give us an error, but it actually parses correctly. All right, so I think that's probably the end of our parsing, messing around side mission that we've been going on. Because what we're actually trying to do, and we'll get back to next time, I hope, but we got sidetracked because this didn't parse properly, is type checking variables. So this X is a 3, so it shouldn't work in a while loop. We should get an error. So next time, this time, we got parsing weird stuff like this in the condition for a while loop, even though it starts with a curly bracket, working. When first we got this test for a simpler situation working, and the way we got it working was by, all right, so hang on. Okay. All right. So it's it's a fairly not temporary, but partial solution, because we end up with a tree of, operators that don't use operator precedence. They just use first come, first served. But what we did was, instead of just when we're parsing an expression, instead of just parsing it and then giving up, what we do is we get hold of that first expression, bail out if it's some kind of error. Then we get another token. We bail out if there isn't one, or if there's some kind of error. Bail out if there isn't one, not if there's an error. And then we look for, if it's an end marker, we put it back and just stop. But if it's not an end marker, maybe it's an operator. If it's an operator, like less than or equals or something, then we call operation write operand and return the result of doing that. Otherwise, we give up. And operation write operand will itself call expression for the right-hand side, I think. So I think chained expressions of this plus this plus this plus this should work. But now I'm doubting myself. Does it call expression? Let's have a quick look. We won't, if it doesn't, we won't like fix it now. But there's a simple, yeah. So it does indeed call expression. So I think my story is right, that therefore if there's a chain of operations, it will get parsed, but it will get parsed into kind of an odd structure, which has nothing to do with operator precedence. So that's something to think about another day. And in fact, we'll get back to type checking, but maybe a to-do would help here. Other than that, we made operation write operand. Instead of taking in the left-hand side as just always being a token, now we just took in a syntax tree. Here's the actual syntax change to the function signature. And that meant that we could do this recursive thing of the thing on the left isn't just necessarily a token. And that's why the thing on the left doesn't have to be a token anymore. It can be a whole expression. All right. And like, I think it could be like a while statement here. I think while statements can be expressions. Anyway, that would be very exciting, wouldn't it? Hope you enjoyed. As I say, back to the thing I keep avoiding because I'm really scared of it, of type checking, or the beginnings of type checking next time. See you then.